Alright, so welcome to part 2 of Lab Assignment 6 in the surface editing. So we'll start off here with this surface that I just drew using the simple sort of rectangular plane command, right? Just like that, okay? Now you'll note that if you draw a plane using this method and you use F10 to turn the points on, there's only 4 points. And you can only sort of do this basically, right? This is the extent of its editability, and well, at some point it actually starts to fold on itself if you do something like that. But that's about how much it can be edited. Okay? Now, so this next command is actually used to sort of reformat, if you will, surfaces to get them to add editability to them. Now I'll show you on the side actually a simple line, normal line like I draw like this, right? This is the same thing. This is a sort of normal line. If I turn the edit points on for this, same thing, like F10, I also have only just the 2 edit points. So you'll see me sometimes do this if I need more edit points. I'll do this command called rebuild. In a rebuild, it tells me how many point counts I have. And so if it's 3, and you'll see that then I get an extra point is 4, then I get more extra points and let's say okay. And if you turn on their edit points, then you'll see I got 1, 2, 3, 4. And they start behaving differently because this now becomes a sort of editable NURBS curve, right? And so that's a straight line. Simply because when I rebuild it, I made it in a 2-degree curve, and this is stuff that we covered in really earlier on in 3D geometry. If it's a 1-degree curve, then it's basically these sort of straight lines. If it's 2-degree curve, then it starts to do that. 3 degrees, then it gets looser, etc., right? So that's what the sort of rebuild command does. Okay, so this is the surface version of what I just showed you. And if you rebuild, then you get the rebuild surface sort of dialog box, right? And you'll see here I say U12V8. So U, let's do 12, V, let's do 8. And it gives you a sort of preview of the surface subdivision, right? And actually you probably want this, yeah, degree 3. Say okay. All right. And so let's just copy this over again. Now that you'll see that F10 plus gumball. So with your gumball on, I'll use F10 to turn on my edit points. And now you'll see that I got a lot more edit points than I originally had with this surface, right? Okay. So after rebuilding it, what I usually do is I just sort of mess around with it. And you can just sort of select some of these points and use the gumball and the sort of blue arrow to sort of just like, drag some of these up and down, kind of make it into a sort of undulating topography, if you will. Right, give it a little bit. And you can select these sort of individually, right? I'm just sort of doing crossing selections because it's sort of easier that way for me to manipulate. And just, mess around with it. None of these are meant to be identical anyways. Okay? Alright, and then you can escape to get out of the sort of point editing mode. So this is sort of a series of operations that work off of an initial surface like this, okay? And this is my original framework, but what you'll get is going to be different from this because the way you manipulate this surface is different from what I had, and this is actually the previous one. So this will be different, and I'm going to delete these as I go along, but they're there to kind of serve as visual reference so you know what we're trying to do. Okay, so first thing I'm going to do, I'm going to copy this guy over. So ExtractIsocurve. I'm going to show you this command first. ExtractIsocurve. Select the surface for isocurve extraction. By default, it'll probably go in one direction or the other. You'll see you have some options. The direction toggle changes the direction. So these are basically the surface isocurves that you saw earlier, and I can actually choose to extract them at any point on the surface. There's extract all, right? I can toggle it again and then extract all, which kind of gives me this sort of regular grid of isocurves. While extract all kind of does it based off of your original isocurve or rebuild density. But if I actually run the command, I can actually pick, like if I want one in the middle or somewhere else, then I can actually pick where I want more sort of precisely. Okay, so if I delete the surface, then you'll see you have this basically. You'll have this sort of wireframe. And so instead of deleting it, I'm going to delete my original one. I'm going to use the selection filters here. And this is, I use this a lot, select last created object, right? And the text command for that is select last, right? Select last. Although I just do this, it's a sort of shiny box, right? In the selection filter. Select last and just move it using snapping the midpoint, just move it over here. Okay, so you'll have this sort of wireframe of it. Okay, let me delete these. So loft in the U direction. What that means, and let's just copy this twice. Copy up here, 1, 2. Okay, so lofting in the U direction, which is right here, it's the X direction. So let's just try to get a good angle, and I am going to try to delete these, right? All the horizontal ones. Okay, and select them all together and just do a loft. Okay, so you'll see the loft just sort of follows your cross-section curves, and if you try it in the other direction, this time deleting everything that's sort of horizontal, all right, and do the same thing, loft. And you can actually sort of compare the surfaces. I think in this case they're actually fairly close when they overlap. Yeah, they look fairly close. You'll run into some situations where, based off of the accuracy of your lofts sometimes, or the density of your isocurves, where these two surfaces actually don't match. Okay, so I'm going to delete all that and just copy what you made, over, so it's accurate. All right, this command is called the NetworkSrf. The NetworkSrf is a more accurate version of sort of reverse engineering this. It requires basically these sort of 4 sides, 1, 2, 3, 4, as a sort of closed edge, and then cross-section curves going in both directions. So you can select everything together and run the NetworkSrf command, and you'll see this surface from curve network, right? And A, B, C, D. And if you preview it, it'll give you an idea of what you're going to get. And you say, okay. So this will have a sort of denser isocurve density, but it will probably be the closest to what you had originally. All right. I'm going to come over and delete these as well. And let's copy this upwards using my midpoint snap. Okay. If you haven't noticed, actually the scrolling zooming behavior actually will zoom towards in the direction of your cursor. So I use that a lot if I'm dragging things around and I don't want to click. Sort of if I zoom in here, and I zoom out there, it will actually, you can actually navigate this way based off of where you're pointing your cursor when you zoom. Okay, so that's a sort of trick that you'll get used to. Okay, so here, patch without boundary. So actually we're going to delete these. So the patch command is actually a way of fitting a surface through whatever you give it. So this could actually be lines, points, or some random things, and they don't actually have to match. And you'll see what I mean. Actually, you'll see that, for example, the network surface will require these to touch, especially on the edges, right, for it to work correctly. Well, the patch actually is not so finicky. The patch is a bit more rougher, and you'll see that, okay, I'm just gonna move some of these, right, slightly out of plane, like that, so they're not as precise as they were, right, so they don't touch anymore. Okay, the patch won't have a problem with that, and that's why it's so great sometimes. The patch command, okay, so you'll see the sample point spacing, 0.5, U span is 40, V span is 20. That's the sort of precision, right, or how dense you want it to kind of do it. So, and you'll see it still will be able to give you a surface, and that might not actually work in this. Okay, and you'll see that there's some place, okay, you know, it's trying to fit, right, between like these this sort of contradictory information, right? So you can sort of rebuild it with less, and that actually sometimes will give you a better fit. But you'll basically see what that means is that, like, you know, it's a sort of interpolation between curves, and this is the same thing, except you'll see that when I kind of give it, when you give it a boundary, it will actually clip to the boundary a lot better, right? But this is actually just to show you that, okay, you know, the patch surface is one that is able to tolerate some degree of deviation from in terms of the geometry that you give it. Like, it's able to kind of interpolate and work in between. Okay. So let's see. Now this actually should be, let me delete this. This surface, you should actually take your original here and just copy it over. Okay, so this last little bit, the contour distance. The contour command is really cool because it's what we use to actually create, well, topography contours. Before I do this command, I like to do the project to C-plane. Project to C-plane, don't delete the input object so you still have it, right? And then duplicate face borders, duplicate face border of that. So I have this sort of framework that's around it, right? And then I move vertical, and I snap it to the lowest point of the, well, roughly the lowest point. I think the lowest point is actually there. Snap one corner to the lowest point I can find on the geometry. Actually, one other way of doing this is actually a faster way. Bounding box and enter, which actually gives me the bounding box of that, right? And then I'll duplicate the face border of the top and the bottom. Enter, and then delete the bounding box. So what I'm looking for is basically, you know, something that crosses the very bottom and the very top of whatever geometry I have. All right, and then contour. Select objects for contour this, enter. Base point, which is one of these which is this corner, and then direction perpendicular is that, right? I'm going upwards. And then distance between contours, I think we put 0.2. Enter, and then it'll do that, right? So this basically gives you the contours of what a surface, actually whatever, it will work on poly surfaces as well, right? So actually the variation to this, if I just copy this out, especially eventually when you guys want to do something for laser cutting. So extrude, not as a solid, as an open sort of ended upwards that way, right? So you have this sort of walls around it. You take the surface and you trim off the excess, right? And so you have this, which you join together, and you cap it. So it's a closed box now, right? And then you run the contour command on this. Enter, base point down here, up there, 0.2, enter. Okay, so I'm going to move this to the side. And what's so great about this is that actually now, actually you can, because these are all on their own sort of horizontal levels, right? I can select them all and join them. And it will join whatever it can, right? In some cases, actually that, I don't know why that's missing. That might actually, you have to put that back together or something. Yeah, but what you can do is actually, these are actually the sort of cutting lines for each and every layer of the contour, as closed lines, right? So eventually what you can do is go to one of the side views. Let's see. Yeah, no, not this one, front. Okay, this side view, right? And you will be able to, or you can try by kind of selecting all this stuff together, right? And you can actually just sort of lay them out like that. I select everything together and I go to the next layer, and by holding down the control key, holding down the control key, I can deselect the last layer, pull it out, then deselect the last layer. Sometimes you'll have multiple, but that basically allows you to spread it out. If I go back to the percent, right, and just have to be careful because sometimes you'll have sort of stuff on the same sort of contour layers, right? So you might have more than one patch of things on the same sort of Z height, but basically you can actually spread it. Then this actually is what you would put into the laser cutting for cutting a large contour model like this. These, because they're all closed curves, you can actually extrude them all together. And let's see, 0.2 solid, 0.2. Right, so this is what that model would basically look like. This is a solid contour model, as if it was cut out of chipboard or museum board, foam core, etc., etc. Okay, so that's a sort of nifty little trick. Let's get back to this. Okay, so that's that going in one direction. Okay, now if I select this, let's just copy this over. 1 and 2. Okay. So delete. We can delete this, and I'll just actually this one will delete the surface. Okay. For this one, we'll delete this and this, but we will duplicate the face border of the surface. So we have that. And this is to show you the difference. So the patch without boundary, if it works on something like this, run the patch command. Same thing, right? We don't change any of this. If you preview it, you'll see it takes a while to calculate. I actually think this is messing it up, so I'm just gonna delete those 2 line segments. Okay, so let's try that again. Patch. Trim, okay. So you'll see that this actually kind of failed. It did this instead. And if you go to the version that has a boundary, right, and you patch that with the same settings, patch and say OK. This one will actually kind of work, right? And so you'll see that actually, sometimes this sort of extra information is somewhat important. I think it's probably the corners. Let's just try this. And this is actually a modeling technique I use a lot. So I'll draw a line, and I know this is on ortho going in one direction. I'll snap a corner, like hovering over it, and sort of drag it over that way towards the sort of apparent intersection of these two. And you'll see this sort of cursor pop up perpendicular intersection. That's actually the intersection of this corner point, right? So I use that a lot. So if we do the same for all these guys. Oops, I didn't get that one. You kind of have to follow it a little bit. Okay, that's pretty small, so I don't worry about that. Okay, let's try that again. And I can click on preview just to see what we get. Okay, so you'll see that now that actually works, except, because it doesn't have a very explicit outside boundary, it doesn't know what exactly you want to trim the surface by, right? So in this case, you will actually have to grab, let's say, this, copy it over and, use that as the sort of trimming sort of boundary to kind of trim that out, right? Because it's just what the patch command is trying to do is trying to fit a surface through whatever you have here, right? And sometimes, it's seeing you're missing a lot of information in one corner and just won't do it correctly, okay? But the patch is sort of like a more looser, forgiving, but an approximate way, because you'll see that these lines don't necessarily really line up, right, with the surface. They kind of go in, pop in and out. It's a more approximate way of actually fitting a surface through some general information that you're giving it. Okay, all right. So that's sort of part 2 of this lab assignment.